Okay, the modulus function. Notation for the modulus function is two vertical lines, and it basically turns negative values into positive values. So you can think about it as giving you a magnitude. Mathematical version of that is modulus of x equals, so we've got two separate definitions. If x is 0 or positive, it's not going to change x's value. So modulus of x is just x. If x is less than 0, then the modulus of x is minus x. So, for instance, the modulus of 2 is equal to 2. It's not going to change it, but the modulus of minus 2 will be minus negative 2, which is 2. In terms of sort of solving very simple equations, we're going to actually use graphs to solve equations, but if you have the modulus of x is equal to 5, then there's two options, either x equals 5 or minus x equals 5, i.e. x is equal to minus 5, so that when you take the positive value you get 5. You can just extend that very slightly before we go into the graphs. So for instance, if the modulus of 5x minus 1 is 4, then you could have 5x minus 1 is 4, or you could have minus 5x minus 1 is 4, i.e. 5x minus 1 is minus 4. So that when you take the positive value of what's in the modulus, you get 4. This one here gives me x equals minus 3 over 5, and this one here gives me x equals 1, so adding 1, dividing by 5. So essentially, if the modulus of 5x minus 1 is 4, 5x minus 1 is going to equal to 4, or it's going to equal minus 4. So when you take the positive value, you get 4. The first thing we're going to focus on is sketching. So I'll go over a few sketches. So the most straightforward is literally just sketching y equals modulus of x. So, sorry, my family are really rustling away in the background. When x is greater than or equal to 0, modulus of x is x. When x is less than 0, the modulus of x is minus x. So the equation of this line segment is y equals x, and the equation of this one is y equals minus x. This is important because we need to come back to this when we do equation solving in a bit. Essentially, this gets reflected up off the x-axis. So this line would naturally come down like this, and it's being reflected in the x-axis. That's the transformation that's taking place. It's like having y equals minus f of x, so that reflects you in the x-axis. Right, just extending that slightly. So if we look at y equals the modulus of x plus 3, you can do the things you normally do, i.e. find x and y axis intercepts. So when x is 0, so I'm putting 0 in there, y equals the modulus of 3, which is just 3. And when y is equal to 0, the modulus of x plus 3 is 0. You don't really need to write this in this much detail, but that means that x plus 3 is 0, and So 0 doesn't have a sign, so it's not going to change sign under the modulus. And so x is minus 3. So it doesn't hurt to actually just pop in your axes-intercepts. So I'm at minus 3 and 3. And again, this gets reflected. It would have come down there. It gets reflected up in the y-axis. Equations of the line segments. So this bit here is y equals x plus 3. This bit here is y equals minus brackets x plus 3, or minus x minus 3, but we'll leave it like that. And I think I want to do another one. Do one more. So let's do y equals the modulus of 3x minus 2. So same process. When x is 0, y equals the modulus of minus 2, which is less than 0, so times it by minus 1 to give me 2. When y equals 0, the modulus of 3x minus 2 is 0, so 3x minus 2 has to equal 0, and x is 2/3. Putting all that into sketch, so if I come back down here, so y is 2, x is 2/3. I'll try and keep some sense of scale with this one. And then we come down onto the x-axis, and then it would have come down, but it reflects up like so. So they're both, you know, steep lines. The equation of the right-hand side, this is where the value of the line is positive, so it doesn't change. So y is equal to 3x take 2, so that's got gradient 3, and this side is y equals minus bracket 3x take 2. So the gradient of this line segment is minus 3, and if you multiply that out, you get minus 3 plus 2, and you can see that y-intercept is at plus 2. Right, we'll do one more video on sketching and just combining some transformations into that as well. Sorry, it's slightly wonky. I think you're okay.